Fifth grade lesson 3.1 is the thousandths place. This one's a little trickier compared to the tenths and hundredths place because we were able to tie tenths and hundredths place to money. Tenths place being dimes, you need 10 of those to build a dollar. Hundredths place being pennies, you need 100 of pennies to build a dollar. So our brains were able to make that connection. We don't have a coin for the thousandths place where they would take 1,000 of them to make a dollar. So our brain takes a little more to wrap around it, but let's take a look at it. How can you describe the relationship between two decimal place value positions? If thousandths are smaller parts than hundredths, like pennies, it's smaller than that. If 100th is divided into 10 equal parts, then each part of that is going to be a thousandth. So if you took one penny and divided it into 10 equal parts, you'd have 1,000th of a dollar. We're going to use the model at the right to show tenths, hundredths, and thousandths place. They want us to divide the larger square, this one, into 10 equal columns or rectangles. So there, I've done that there. And then they want me to shade in the 1/10 there. One of, what part of the whole is shaded in the rectangle? Oh, they said shade one rectangle. What part of the whole is shaded rectangle? So let's shade it or color it in or whatever. One of the rectangles, that's one of them. And of the whole entire one, how much of that is shaded? It's 1 out of the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 columns, right? So that is 1/10, which also can be written, it can be written as a fraction, 1 out of 10, or also can be written as 1 in the tenths place, 1/10. Now they say divide each of these rectangles into 10 equal squares, and we'll use a second color to shade in one of the squares. Let's do that. Okay, I've done that. And I'm going to use a different color to shade in one of the squares. I'll do this one over here. Right there, I shaded that in blue. It's hard to tell that I did that there. Let's go with green. Let's see if that's better. There we go. That is 1 out of how many chopped up pieces am I looking at now? It was 10 this way and 10 this way. 10 times 10, right, is 100. So I have 1 out of 100 here. So 1 out of 100, or 1 in the hundredths place, 1/100th, or 1 penny if this is a whole dollar. That's 1 penny. I would need 100 of them filled to make the dollar, correct? Now, they say divide the enlarged hundred square. So they took this square and they pinched it out and zoomed it out so that it's bigger so we could see it, because I don't want to be drawing those 10 lines in there. Are you kidding? That'd be crazy. So they zoomed it in for us so we can do this better. Divide the enlarged hundred square into 10 equal columns or rectangles. If each hundred square is divided into 10 equal rectangles, how many parts will the model have? Well, let's divide that into the 10 like we did initially with the whole. But now this is 1/100th being split into 10 equal pieces. Okay, that was kind of hard to squeeze those in there. And then I'm going to shade in one rectangle. This, if it were over here, would be like right up against there, barely, barely, barely in there. It would have been too hard to do with such a tiny space. So if each of these 100 squares had 10 pieces in them, isn't that just 100 times 10, right? We would do 10 plus 10 plus 10 plus 10 plus 10 plus 10 100 times, which is equal to 1,000. So we have 10, one of those tiny, tiny ones broken into 10 pieces, and there's 100 of them. So we get 1/1000th. So we shaded it in. I already shaded it. I guess I got ahead of myself. And we had that little shaded part is 1 out of 1,000 pieces. If we cut all of those that way, that also can be written as a decimal as 1 in the thousandths place. So we have the tenths place here, the hundredths place, and now we have the thousandths place. All right, and the next page asks us to draw some conclusions, to come to some connections that we can make about this information. First, explain what each shaded part of your model in the investigate section shows. What fraction can you write that relates each shaded part to the next greater shaded part? Okay, Well, when I started with this one, this whole one, I had only divided them into 10 pieces. So 1/10 or 0.1 was how much I had, 1 out of 10. When I cut it this way 10 times, that was 10 times smaller than this little one. So it takes 10 of these to make one of these. So 10 times 0.01 will equal that. I need 10 of those. 1 penny. This is easy for money because 1 penny, if we need to make a dime, we would use 10 pennies, right? 1/10. Okay. What about this one compared to this one? That is 10 of these rectangles here make one of these. And it takes 100 of these to make 1/10. So we have 10 times 0.001 that equals that one. Explain or identify and describe a part of your model that shows 1,000th and explain how you know. The zoomed in box was split into 10 equal pieces. One of those equal pieces was 1,000th. I wrote it as the zoomed in box, which was 1/100th. The zoomed in box is 1/100th, and we zoomed that 1/100th in. The zoomed in box, which was 1/100th, was split into 10 even smaller pieces, and one of those is 1/1000th. Hopefully those connections were made and you kind of see where we're coming from on that. And now let's make some connections here. The relationship of a digit in different place value positions is the same with decimals as it is when we did whole numbers. They were 10 times more as you got higher and higher. You can use your understanding of place value patterns and place value chart to write decimals that are 10 times as much as or 1/10 of a decimal. So here we have the ones place. 10 times more than the ones place would be the tens place over here, right? 10 times more than that would be the hundreds place over here, and the thousands, and on and on. Going this way, it's 1/10 of it, or taking this one and dividing it into 10 equal pieces. If I take a $1 bill and I divide it into 10 equal pieces, I have dimes, 10 cents. One of those is a dime, or 1/10. If I take that dime and I split that into 10 equal pieces, that's 10 pennies. One of those is a penny, the hundredths place. I don't have a coin that represents 1/10 of the penny. We can chop it up if we wanted to, but pretty worthless anyways. But 10 less, this number divided into 10 equal pieces now becomes the thousandths place. So here they say, what number is 10 times as much as 0.04? Well, from here, 0.04, 4 hundredths, this is 4 sitting in the hundredths place. What is 10 times more than that? It's going to be 4 tenths. We just multiply by 10. So 4 tenths. Because to go this direction, we just multiply by 10. And since we know 4 times 10 is 40, 40 cents is the same as 4 dimes, right? What about going the other way? It's 1/10 of that. And again, when we're multiplying or dividing with tens, we get to just move decimals around. This one, we moved the decimal from being over here, we moved it in this way. We moved it to the right because our number was getting bigger. Since this time our number is getting smaller, we're going to go the opposite direction, and we are going to get 0.004, because that is 4 thousandths is, would take 10 times 4 thousandths to make 4 hundredths. So that's how that works. You're just moving that decimal around to kind of make those adjustments if you need to adjust like that. Use the steps below to complete the table. Write the given decimal in a place value chart. If my decimal is 0.03, that is 3 hundredths. What is 10 times as much of that? If I have 3 pennies, 3 hundredths, and I multiply that by 10, I now have 30 cents. How many dimes or how many tenths is that? It is 3 dimes. Okay, if I chop those 3 pennies into 10 pieces each, now I have 30 of those hundredths, and that gives me oops, I need the pen, 3,000ths. And notice the comparison of your decimal here, getting more money here. It moved over closer to the decimal. And when it was that penny being chopped into pieces, now our decimal is way over here compared to our 3. If I have 1 dime, what is 10 times more than 1 dime? If I have dimes and I have 10 of them, I get one whole dollar. If I have 1 dime and I chop it into 10 pieces, 1/10 of that dime, I end up with pennies place. 1 penny is 1/100th of that. Finally, I have 7/100ths, 7 pennies. 10 times 7 pennies is 70 cents, or 7 dimes. And now 7, each of those being split into 1,000 pieces, it puts me in the thousands place. 7,000ths. 7 is living in the thousands place. We have the tenths place, hundreds place, thousands place. Not thousands, thousandths. This is all, everything on this side of the decimal, remember, is that ths at the end without spitting on people. Try not to spit on people when you say it. Tenths, hundredths, thousandths. THS at the end. All right, let's look at our share and show and see if we can put this all together making sense. They want us to write the decimal shown by the shaded part of each model. Okay, I see that this whole thing is one whole that is split into 100 pieces. Of those 100 pieces, I have 10, 20, 30, 40, 50, 60, 61, 62, 63, 64, 65, 66. So right now I have 66 hundredths, but notice they have this one like zoomed over here. So now they've taken one of these little hundredths and cut those into 10 equal pieces. There's my thousandths place. How many of those are there? 1, 2, 3, 4, 5. 5 thousandths. So what I have here is 665 thousandths, because now we're just calling all of these thousandths too. So 665 thousandths is how you would write that one. Probably need another one to see how that works. Okay, again, we have one whole, and we have it cut into 100 pieces. So how many of those 100 pieces are shaded? 10, 20, 39, 39 hundredths. I'll go ahead and write 39 hundredths, but there's more. But wait, there's more. This is the one. They zoomed it out so we could see it better, and they cut this one into 10 equal pieces. Of those, there's 1, 2, 3, 4, 5, 6, 7, 8 that are shaded, and that is 8 thousandths. So we have, of all of them, now we can just call this all 398 thousandths. 398 thousandths is how you would read that. And you could even look at it in terms of your place values. I have 3 tens, 1, 2, 3 tens, full columns. I have 9 hundredths, and then I have 8 thousandths. 398 thousandths is how you read that. Let's have a look at this next one. I have one whole. It's divided into 100 equal pieces, and I have 10 and 8. So 18 hundredths. But wait, there's more. This one is cut into 10 equal pieces, and I have one of those tens there. That's thousandths. This is 181 thousandth. We can put the 0 in front of that. 181 thousandth. Okay, what about this one? What are they doing here? One whole thing, and all of them but one is colored in. That is 99 hundredths. And they zoomed and said, wait, there might be more. And then they teased us and said, no, sorry, haha, there's not. I can put the 0 here because 99 hundredths is the same as 990 thousandths. I have 99 hundredths and no more after that. So 99 cents. I didn't cut that next cent. Well, I may have cut up the next cent there, but I don't have it. I don't have that money. So we could say, we could either call this 99 hundredths, or we can call it, if you really, really feel the need to, you can call it 990 thousandths. That's fine. Either way. Okay, so hopefully you have the hang of that, and you'll be able to do that on Think Central just fine on your own. Let's complete this sentence. 6/10 is 10 times as much as. So it's 10 times more than what number? It's 10 times more than 6 pennies, because 6 pennies times 10 gives me 6 dimes, 60 cents. Okay. 7/1000ths is 1/10 of what number? So I need to multiply 7/1000ths by 10 to find out which is the one that's just bigger than it, because 1/10 means he is the smaller number of the two. So let's multiply that by 10. That's really just going to move him closer to the 0, 0.07. 7/100ths times 10, 7/1000ths times 10 will give me 7/100ths. We have 0.008 or 8/1000ths is 1/10 of what number? So this is the smaller amount. So we need to know what was the bigger amount that we cut up by 1/10. And we could see like this is the part we cut up, right? So we need 0.08. 8/100ths divided into 10 equal pieces is going to give us 8,000. And then 0.5 is 10 times as much as what smaller number? If it's 10 times as much as, that means we're comparing it to a smaller number. 0.5 is bigger by 10. So what number would I multiply by 10 to get 0.5? I would put 5/100ths, because 5 pennies times 10 gives me 50 cents, 5 dimes. Okay. Notice we're just moving that decimal depending on where we're going. Are we going larger or smaller? If it's 10 times as much as, then we have this number being the bigger number. If it's 1/10 of, then whatever this number is the smaller number. I need to find which one is the bigger number. But it's all about moving the decimal around. And having these charts filled out, you might find that helpful. Decimal is 2/10. What's 10 times that amount? If I have 2 dimes, 10 times that's 20 cents, right? And 10 times that is $2. What's 1/10 of 2 dimes? That would be 2 pennies. What about 7/100ths? What is 10 times as much as that? 0.7. I'm hoping you're kind of start seeing the pattern come along here if you haven't already. And what is the smaller version of that 10, the division by 10 divided by 10? It's going to be 0.007, 7/1000ths. This is 5 pennies. What's 10 times the amount of 5 pennies? 5 dimes. 5 pennies times 10 is 50 cents, 5 dimes. And 1/10 of that, so if I have 5/100ths and I'm going to chop that into 10 pieces, then I'm going to have 5,000ths. 10 times the amount of 4/10ths, 4 dimes times 10 is going to give me $4 or 4.0, or just 4 you can even call it. And what's 1/10 of 4 dimes? If I cut those 4 dimes into 10 pieces each, that's going to push me over to 4 pennies, 4/100ths. These are smaller amounts here, and these are larger amounts than this one here. Okay, you may want to pause and try this one and see if you're getting it. So give it a try and then push play to check it. Number 13, 6/100ths is 10 times as much as 6/100ths is, hopefully you got 0.6. Did you get 0.6? I hope so. And 1/10 of that is going to be 6,000ths. What about 9/10ths? 10 times as much as that is 9.0. And 1/10 of that amount is 9/100ths. Moving that decimal back and forth, that's it. 3/10ths, 10 times 3/10ths, just move that decimal over 1 to make that go bigger. 3.031s, we can just call it 3. And if I want to make that 1/10 of that, this is going to be all cut up by 10. I'm basically moving my decimal this way now. 0.03 300ths is 1/10 of 3/10. And what is 10 times as much as this 1.08? 8 times 10 is 80 cents. 8 pennies times 10 is 80 cents. So that is 8 dimes, 0.8 or just 0.8. 1/10 of that is going to make us tinier, 8 thousandths. I hope working through these patterns helped. You're going to probably want to keep this book page out in front of you as you do Think Central to help keep your mind grounded on this. You do get used to that thousandths place, but like I said, it takes a little extra practice because with the tenths place, we had dimes to kind of hook that knowledge onto. With the hundredths place, we had pennies to hook that knowledge onto. And with the thousandths place, we don't deal with a lot of anything pretty much in the thousandths place. So it's hard for our brains to wrap around. Just give it time and be patient. Use this page to help you as you work on Think Central. Good luck.